Welcome to Kiln Bill Part 1. All right, so I picked up this beautiful kiln on Facebook Marketplace, and here is me putting it together. Now, each of these layers are made of a very lightweight heat brick, so the unit itself was actually pretty lightweight. And so first thing I did was I wanted to test the lines to make sure that the heating elements were all in good shape. The main issue here, at least in my studio, is that this thing requires 240 volts and I don't have a plug. So I spent the better part of 2 days or so putting together this conduit with a 60 amp breaker in the front. And then I got the correct plug and I was able to finally plug this little beauty in to give it the raw test run. So this thing basically has an on-off switch. I then was able to switch it on and give it a test run and then have a look at these awesome thermals. You can see I got this up to 1,000 Fahrenheit. I checked this heating, this kind of red hot heat in the corner, pretty normal. So everything's looking good. Now, one thing I had noticed, and I'm going to really speed through this because it ended up being something that I removed, was I wanted a way to be able to lift the lid of this kiln without just taking it off manually. The lid weighs 30 pounds, so I set up this counterbalance system. This thing also took a long time. I had to put this kind of special clamps on the side of the lid in 3 areas, and then I put a couple of pulleys in the top, and I was able to get the system working with 27 pounds of counterweights. Now, I know it looks pretty cool. Once I had it finished, like, this counterweighted system was pretty cool, but in its resting state, i.e. with the lid closed, it actually put a kind of a stress or something on the lid, which made it so that there was a little gap around the top of the lid. Now, if you know anything about kilns, you know you definitely don't want any gap. And so I ended up just removing this thing, and it was a waste of time.
And so that brings us cleanly to the whole point of me buying this kiln, which is that I want to do some pottery. Now, as I've mentioned in several of my videos, I am an artist, and I have always wanted to experiment with pottery, so this is nothing new. However, with this kiln, I had also inherited a couple of bags of clay. The first one was actually okay, but you can see that it's dried out, and I definitely couldn't work the clay. So I knew that I needed to get this thing rehydrated, and the way to do that was to cut it into slices and then spray each slice with liberal amounts of water. Now, I couldn't even slice this clay, and I didn't have this clay cutting tool that I needed, and I didn't want to wait for it to come, so I just made my own out of some 2x2. I sawed it into kind of a roughly hexagonal shape, and then I drilled a hole and put a cable through it. I spent a good while just spraying this older clay with water and then bagging it up and then waiting for it to rehydrate. Now, the second bag I got was quite a bit drier, and that's because it had a hole in the bag. So I patched that hole up. So I couldn't use my cable slicer, so I ended up just using a knife, and it was really hard cutting through this clay, but I did manage it, and I had to spray plenty of water into this clay, way more than the first bag. But in the end, I rehydrated the clay.
So as I was waiting for the clay to rehydrate, I started looking into what it would take to fire this particular clay. It turns out that this clay is a low fire clay, so it needs a very low temperature. So this machine is powered by an on-off switch. In other words, the elements go full blast, and then there's a special thing called a pyrometric cone that you put underneath the switch. When that cone absorbs enough heat, it softens,
and the switch releases the heat, turning off the kiln.
But in order to fire this low fire clay with that switch, it would have required a lot of babysitting over the course of about 12 hours, and it would have meant fidgeting with the top, putting bricks in there to create air flow, etc., etc.
Now, that's not something that I wanted to do. And the idea was I would make a control box for this 60 amp kiln, and I would get it to be able to fire
whatever I wanted it to do. Now, there's already some software out there called PID Kiln.
So I decided to start the build on the premise that I would basically be using that software for my kiln controller.
But this kiln controller needs a massive amount of energy. It's nothing like an espresso machine. An espresso machine may need something like 10 amps or something like that, but this kiln is 50 amps. So I knew that I needed way beefier components, and I started looking into exactly how this controller should be wired for safety and for functionality and for longevity. So
I ordered a whole bunch of parts and I got into the build.
So this is roughly how it's going to look. Now I'm waiting for one more of these breakers. So it's going to fit right in here. And I'm waiting for a new SSR. And then this fan is going to fit inside, but I'm going to have to cut that backing plate a little bit with a hacksaw. These 4 20 amp plugs are going to be providing power to the elements. The intake, I believe, is going to be, I'm going to cut a hole in here from the side and take in the 6 gauge wire from the plug. That's going to go into here, which is the definite purpose contactor. And then that's going to be controlled by your A1, A2, which is going to be also AC, but that AC is coming from this relay right here. So one of these sides, we'll say R2, is going to go to one side of each of the 4 breakers. That's going to go straight to one side of each of these outlets. And then the other live from the contactor is going to go into the SSR. That output's going to go to a terminal, and it's going to go to the other side of each of these 4 breakers and then to the other outlet. So that's pretty much the AC side. I'm going to take 2 18 AWG wires to this fuse box. These are 2 amp fuses. This is going to power AC/DC adapter, which is the power supply for the board. And one side's also going to go straight to this relay, so it's always going to be powered on. The other side's going to go a 240 volt relay, and then that is going to control this contactor, so the other side will go over to here. Now on the DC side, this adapter is going to provide power to the board, and then the board is just ESP32. That's going to be controlling this relay, and it's going to be getting info from this board here, which is for the thermocouple. Yeah, it's all pretty straightforward. The wiring is going to be simple enough. Programming ESP32, I have no clue how to do that yet, so that's going to be fun. But the actual code is PID Kiln, which is already out there. I already tapped 3 to M5, so just gonna tap the 4th one for you. This is the first time I've successfully tapped a, whoa, look at that. I'd say that looks pretty good. We got our board there, relay, we've got our fuse, controllers here. So we need one more breaker. I feel like I just ran a marathon. I look like I just ran a marathon. I don't look this way usually. Man, this thing was crazy getting these wires in. Okay, so the AC side's done. I'm going to flip the camera around, and I'm going to show you what I'm looking at here. I'm even hesitating to show you that last shot because of how terrible I look. Boy, this thing almost beat me, man. Unbelievable. Anyway, so we got the outlets. Each outlet is going to a breaker. That 240 gets split. So the contactor, one of them is going straight to the breakers, then to the outlets. The other one is going to the SSR for fine-tuning control. That is getting split out across the breakers on the other leg. So I've used red for the un-SSR'd leg. In other words, the contactor only leg is red, the SSR leg is black, and I had to use these giant 6 AWG wires all the way up to the breakers. That was the most annoying part of this build. Was the only thing left to do now is the DC side and the logics. Good morning. Okay, I am fresh and I had a whole day off since fixing this. So today's plan is to basically finish this thing. Okay, well, actually, one update is I really don't like this wiring jig that I did. So I've ordered something called a 2-phase bus bar. So hopefully that will connect all these terminals together, but across phases, so I can just put one wire into one end, one wire to the other end. That's going to clean this up a lot. So today we need to get the AC out of here, over to the fan, over to this adapter, and then also over to definite purpose contactor over here. I think the layout is pretty good here, so I'm happy with that. All right, so I'm going to lay the way for the AC adapter plate here. I need to clear all of the solder on both sides. Decided to give you guys a close-up of my amazing soldering work here. So let me know in the comments, what do you rate me out of 10 here on my soldering? Ooh, that was a good one. All right, what do you think? Look at that. Pretty good, huh? All right, we can escape the inevitable. No longer we're going to actually have to do the real stuff, which is wiring all this stuff together. Okay, as far as I can tell, the control board and logic is complete. So I've got the thermocouple board here, but the AC adapter will go there, and then the ESP32 will go here. We should have wired up everything correctly, and I marked these. So we've got the SSR out. We've got the small relay, which is going to power the definite purpose contactor. And we've got the AC supply here, which is what I just epoxied in. All right, so I'm going to get this into the main box, and I guess we're going to fire it up. Let's move on. Okay, so I've got the board. I'm just going to be connecting all this up. Okay. I think we're done. Oh, better put this guy in. So before I power on, it's worth just noting, first of all, that I have not connected the SSR, as I said. So this should see a voltage. We'll put it onto the multimeter and check. But let's verify the connection. So we have the AC coming here, feeding into the fuse off. That relay is going to be switched on and off to power the main contactors. Power supply is going to the AC, to the DC side, so that wiring looks correct. It's really time to just plug it in, and we'll see what happens. Hopefully it all goes well. Now, one thing I've learned from my limited YouTube experience is that you should always be filming in case something blows up, because it makes the best thumbnail. So I'm about to plug it in. Ready? Here goes. And we're in. Fan powered up. Oh boy, yeah, so obviously I was expecting to see some lights there. So it turns out that my AC input on this
little black adapter. The pin was not quite lined up, so only one pin was in. So here we go. Switching it on again, and this time I tested the adapter and it should be working. Oh yeah, baby. So there we go. We got some lights. Oh yeah. It's looking good.
It's 8:30 here, and after a pretty long day of trying to figure this thing out, I finally got it working. So you saw the build, that's where I left off. And then I kind of went into debug mode and didn't film anything because, man, I mean, it was pretty hectic. So just learning how to use the whole Arduino IDE and picking out the control board and stuff, that gave me like a couple hours of trouble.
Now I screwed up with the contactor. So I got that working, and then I started testing the SSR, and then I had miswired this yellow wire to the wrong pin. Let me show you where we're at now, because if I reboot, I get my little test program running, which turns on the contactor, and then 5 seconds later turns on the SSR to heat the actual elements. The elements are plugged in here, so they'll actually go on. Then in 5 seconds it'll shut down. So this is just like a very basic program that I wrote, but it's all working. So as soon as I reboot here, which I'm going to do, reaching into this 240 volt box, I'm going to reboot, and you'll hear and see everything start whirring away here. So that's the main contactor, and that's the SSR, and the elements are heating inside the kiln. The elements are on. Now SSR is off after 5 seconds, and then the main contactor goes off. I'm really happy with where I am right now. I am going to be doing some more testing tomorrow, but everything works. And yeah, so it's time to actually code the PID kiln. So let's get on with it. All right, good morning. Brand new day here. Plan for the day is to get this thing attached and operational so that I can have some fun actually making stuff with the clay, which is why I bought this kiln. So it's definitely taken a lot longer to get to this point where I think I'll finally be able to play with the clay at this point. So what I'm going to do is remove the remainder of this kiln sitter right now, and then I'm going to attach the new PID kiln on there and then program it up. So, all right, let's get started. So the majority of what I was doing yesterday looked pretty much like this. Me on my Arduino IDE, first time I've ever used it, trying to talk to the ESP32 board in box here. So, but today the plan is to actually get the PID kiln software installed. And all right, so that's probably as good a time as any to catch you up on where we are in this kiln project. This is where I have been sitting most of today. I did go and film a really good bit of video with Wendy. That video probably already came out, given the way things are going. I'm probably going to go and edit that video and put it out first. But I didn't do much filming of what's happening here today because honestly, basically all the day that I've been working on this is me. So all you would have seen is, and even in a time lapse, would have been me working forward, me going back, and honestly me leaning down and resetting that ESP. I've gotten so good, my muscle memory, at finding those two little reset buttons so that I can upload. And so I thought this was going to be pretty straightforward. I actually built, and I'm an idiot, so it's not a big deal. But I don't really know why I expected this would be any different. But I went and built this whole bit of hardware based on that piece of software that I found called PID Kiln. And the hardware is fine. Everything's fine with it. But that repository is quite outdated. And it relies on a lot of old stuff that is no longer really supported. So I've been working all day
just on getting this thing to, do anything interesting. I've been looking at other repositories that might work, and it's all, I found a kind of a vibe code, one that was obviously vibe coded and pretty hacky. The problem that I'm facing with PID Kiln is that although the screen and rotary knob input device are optional, they're hard coded in there, so there's no way to just disable them. So that was one of the many steps I've had to do. Uploading the file system was using an outdated library called Spiffs or something like that, which is not even supported anymore. So I had to go and root out all the calls to that and turn it over to something else called LittleFS. That actually worked, so the file system was uploaded. And so now I've got it to the point where it's kind of like starting up, but then it's crashing. What I've come to realize is how much of a treasure hand-coded apps are. I have 2 apps on the App Store that are doing okay. One of them is Open Water Swim, and the other one is Energy Level. And I coded and made both of those years ago, way before vibe coding was a thing, before ChatGPT even was released. So I'm at the point now where I kind of like appreciate how good this PID Kiln software actually is. And that's just because it was hand coded at like 10 years ago. Anyway, I've been working at this for at least 12 hours today, and I have definitely made some progress getting PID Kiln to work. So with that being said, yeah, I almost want to wrap this up and just turn this into like video part 1. And I might look at the footage, see how much stuff I have. And, well, if you're watching this and this is, it looks like this is near the end of the video, then there'll be a part 2 and maybe a part 3. But it's important to remember that the goal of this whole thing was to take this kiln and to make it easy to use. Take those bags of clay behind me and turn them into ceramics, right? Just to express myself artistically. That's what I really want to do. So this is really a tool that I'm trying to get up and running, and I'm going to get up and running. It's definitely been, like everything, a learning experience. But it's interesting because I was just telling someone today that it's important to remember that learning is the most fun thing you can do. Learning to do new things, challenging yourself to do new things, and being bad at it is really fun. Yeah, I'm getting stuck, but hey, that's what this is all about: getting stuck and then working your way out. All right, enough said. Over and out for now. I'll see you in the next one.